Hey hackers, Blue Cosmo from CCS here, and welcome to the Introduction to Cryptography course. Now I'm very excited to record this because cryptography is one of my personal favorite subjects, so I guess we should dive into it. Just a quick little few reminders, I guess, or some requirements for the course. First of all, you need some sort of security Linux system, something like Kali or Parrot, simply because it's going to be a lot easier to do a lot of the things I'm going to show you. You can use a normal Linux system, but you're going to have to install some tools and stuff. I would rather have you guys be able to easily take this course. So just have a security Linux system installed, or you can have it on some sort of virtual box or virtual machine. Python 3 is, you're going to need to have it installed, and I encourage you to learn it. I do have the Python 3 course. I'll link in the cards. It's also on my website. Same as this course is also on my website. And taking the courses on the website is a lot easier because it's split up into different modules and it's easier to navigate through. You can also quiz yourself and different things like that. It's really cool, so check it out. Link is in the description if you're watching this on YouTube. You're also going to need to have a basic understanding of computer systems. I mean, if you're taking this course, I would assume you do have a basic understanding of computer systems, but if you don't, I'll try to make it as clear as I can throughout the course, but the more you know, the better you'll be off, all right? You're going to need to, of course, understand Linux, not only how to use it, or not have it installed, but you'll need to know how to use it, how to navigate through the terminal and things like that. Something else, or the last thing we need to know is basic math, like things like algebra or just some high school level mathematics. We're not going to be doing too much math, so don't worry about it, but it's just good to know, all right? So I guess we can actually just jump into the course, right? So let me show my screen. All right, cool, perfect. So I want to make sure you guys can see that, okay? So I'm gonna go to the left a little bit. Cool. So this is the Introduction to Cryptography course. I do suggest you take notes throughout this whole thing, but however, if you don't want to take notes or if you're having trouble following along, if you are on the website, hit the button in the bottom left that says course overview. And if you're on YouTube, then go in the description and click the link that says course overview, because it will take you to the Introduction to Cryptography course overview, right? And it gives you literally everything you're going to need to know throughout this course. This is basically my script right here, right? We have module 0, which is what we're talking about, all the course requirements I was just talking about. The next section we're about to go into, everything I talk about. This is practically my script, right? Like, this is everything I talk about. So if you're ever having trouble following along, just head over to the course overview and you can read along the README files with me, right? Now, again, I do suggest you take notes because you're not going to learn cryptography that well otherwise, right? So let's talk about, bits and bytes, right? This is our section right here. And again, let's just dive into it, right? So bits and bytes, right? You're already familiar with decimal numeric systems, right? I guess I can go over here, right? So we have decimal numeric systems. All right, yeah, you should be able to see that. So decimal, right? You're familiar with decimal numeric systems, right? It's base 10, right? Which means it's based on like 10 digits, right? These 10 digits are literally 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So you already know this, right? Counting up to 1 through 10. 10 is composed of 1 and a 0. 20 is composed of 2 and a 0. 35 is a 3 and a 5. It's a base 10 system, and it's only using these 10 digits, all right? Now, we also need to understand that there are other numeric systems, okay? There's octal, which is base 8. There's hex, which is base 16. And there's binary. Now, binary is going to be the one we're focusing on in this course, but binary is going to be very important, or the other numeric systems as well are going to be very important to know. So I definitely suggest you dive into those topics. But binary, I'm sure you may be moderately familiar, but binary is based 2, all right? And its digits are a 1, which typically stands for like an on value or like a true value, and then there's a 2, or a 0, and the 0 usually stands for off or a false value. All right, so those are the digits that we're only going to have to be concerned about for binary, right? Because there's 2 digits, 1 and 0, on or off. You're like, okay, so how do we count to 10, or how do we represent other numeric numbers throughout, converting from decimal to binary? Or because it's still a numeric system, the number 10 still exists, or the value of 10 still exists within binary, right? Let's use the number 28 for an example, right? So the decimal version of the number 28 looks like that, right? It's just a 2 and an 8. For binary, it's going to look like this. Now, I know this is probably confusing. You're like, how does this have the same value of this? And I'm going to explain this, right? So first of all, we're going to need to talk about bits and bytes. This whole thing is 1 byte. And 1 byte is composed of 8 bits right here. These 8 numbers, these zeros and ones, these are all different bits. And this whole thing is 1 byte, all right? Just to clarify, 8 bits, 1 byte, all right? And byte as in B-Y-T-E, all right? B-Y-T-E. So just keep that in mind, because if you're going to lose track of that, this course is going to be a lot more complicated the further you go in, okay? So let's talk about how we can get a decimal number into a binary number, all right? So this is where I'm going to take out my drawing tablet. So whether you're writing your notes or typing your notes, however you choose to do it, just follow along, all right? So each bit in a binary number represents a value, okay? And this value is basically 2, and then to a certain exponent from 0 to 7, okay? And I'm going to show you guys this, so that way you guys aren't super confused or anything. So a little bit further down, I'm going to write a B. All right, and this B, we're going to do 8 little dashes here to represent the binary number that would be here, right? Because binary numbers have 8 bytes or 8 bits in them. I'm sorry. Remember, 8 bits, 1 byte. I'm trying to get that in your minds, right? So each bit has a value, and this value can be represented by an exponent, right? So this would be 2 to the 0th power. This would be 2 to the 1st power, 2 to the 2nd power, 2 to the 3rd power, 2 to the 4th, 2 to the 5th, 2 to the 6th, and 2 to the 7th, okay? You're like, cool, so this E stands for exponent, right? Because these are all exponents. So now we need to find their values. So we use a V for our values. So 2 to the 0th is just 1. 2 to the 1st is 2. 2 to the 2nd is 4. 2 to the 3rd is 8. Then it's 16. Then it's 32, 64, and 128. All right? Cool. I'll make that look more clear. It's a 16. All right? Now, we have each bit we can see has a value. This bit right here has a value of 128, right? The first bit all the way at the end has a value of 1. So now we can use this system to virtually represent any number, all right? So let's take our number 28 that we had in the beginning, right? So I'll have a D right here to represent decimal values. So 28. So in order to convert it into a binary number, we need to find the first value that can go into our decimal from our left to our right. So can 128 right here go into 28? No, the 128 is 100 numbers bigger, or 100 digits bigger, 100 values bigger than 28. 64? No, we can't, right? So if we can't go into the value, then we mark it with a 0. All right. So 128 can't go into 28, so we can put a 0 here. All right. 64 can't go into 28, so we're going to put a 0 here. 32 can't go into 28, so we can put a 0 here. 16 can go into 28. So we're going to subtract 16 from 28, and we get 12. And now we can put a 1 here to represent, yes, that is true. It's a true value. Remember how I said on or off values, on or off, or true or false? These are false. These numbers can't go into 28, but 16 can. And when we evaluate that from 28 minus 16, we get 12. And I'll even write that to the side here. 28 minus 16 equals 12. So you guys see how we got this number of 12. All right. Now we just continue the process, but using our new decimal number 12. All right. So can 8 go into 12? Yes, 8 can go into 12. So we'll put a 1 here so we know that 8 can go into 12. And now if we subtract 8 from 12, we get 4. All right. Now, can 4 go into 4? Yes, this 4 right here can go into this 4 right here. So we can subtract that and we get 0. So we know that that 4 can go into this 4. So we'll put a 1 here. Now we don't have any numbers left, so we can just fill the rest in with zeros, right? So that's how we got our 0, 0, 0, 1, 1, 1, 0, 0. 0, 0, 0, 1, 1, 1, 0, 0. So these are the same number, 28 right here. And our binary number of 0, 0, 0, 1, 1, 1, 0, 0, 0. This is the same number, right? We can just see how we converted it from a decimal number to a binary number, all right? So let's go down a little bit and let's figure out how we can go from binary to decimal, right? So we need to figure out how we can go from binary to decimal instead of the invert. So let's say we are given the number, let's give ourselves the number 0, 1, 0, 1, 1, 0, 1, 0, 1, 1, 0, 1, 0. All right. So 0, 1, 0, 1, 1, 0, 1, 0. All right. So let's figure out how we can get the decimal form of this binary number. Well, it's pretty simple. We're just going to do the same thing we did before, but kind of at an inverted extent. I'll show you. So let's take our binary number. We'll have our 8 dashes that we had before. There you go. So our 8 dashes to represent our 8 bits that are going to be there. All right. Then we can have our exponents. Remember, 2 to the 7th, 2 to the 6th, 2 to the 5th, 4th, 2 to the 3rd, 2 to the 2nd, 2 to the 1st, and finally 2 to the 0th. Now remember, if we evaluate this, we get these values. So 16, 32, 64, and 128. All right. Cool. And these are our values right here. Now we can try to find our decimal value. So let's fill in our binary number. So we have a 0, a 1, a 0, 2 1s, a 0, 1, 0. All right. That's the number that we have right here. All right. There you go. So how do we find the decimal number? So let's just mark the value of every time a 1 appears in our binary number. So we have a 64 right here. We have a 16 right here, an 8 right here, and a 2 right here. All right. Now all we have to do is add these values. So 64 plus 16 plus 8 plus 2 is equal to 90. Now you can check my math if you want, but I believe that's correct. That is 90. So this binary number of 0, 1, 0, 1, 1, 0, 1, 0 is 90. All right. So these numbers are the same. Now you're not going to need to necessarily know how to convert them. I just want to show you how to convert them so that way you understand how binary and decimal kind of convert and converge, or basically can have the same values. Now remember that each of these are a bit and this whole number is a byte. Now this is going to be very important because certain ciphers we're going to be talking about encrypt in bits rather than like each byte of a character. So you need to understand that what's being encrypted is these bits right here, these bits, right? So we're going to get into that later. So until then, let's kind of talk about some, I guess, vocab, right? Now vocab is going to be very important in this course because if you guys don't know what I'm talking about, you aren't going to be able to follow along, okay? So I just do a little vocab right here, and I'll make this 18 so that way you guys can see it. Cool. I'll even zoom in a little bit. Awesome. So let's talk about our first vocab word, which is cryptography. Now, cryptography is basically the study and practice of secure communications. All right? So, there you go. So cryptography is the study and practices or study of practice. So cryptography is the study and practice of secure communications, okay? Now, cryptography is also referred to as cryptology. I'll even do a little AKA cryptology, right? So that's what it is. It's the same word, same thing, just two different. It's the same thing, just two different words, okay? Now we're going to talk about encryption. Now encryption is the process of turning readable information, and this readable information is called plain text, all right? And it turns this readable information into unreadable information. Cool. And this unreadable information is called ciphertext. Now I'm going to be referring to plain text and ciphertext a lot to make sure you guys understand this, all right? Now we're going to have to talk about decryption. Decryption is the process of turning ciphertext into plain text. All right? Now, a cipher is the algorithm that encrypts plain text or decrypts ciphertext. I should frame that better. There you go. So a cipher is the algorithm that encrypts plain text or decrypts ciphertext using a key. And you're like, all right, Chris, what is a key? So a key is a secretive set of characters used for the ciphering process, okay? Now, a block cipher, now this is important, or this is especially relevant to what we were talking about here about binary numbers and bits and bytes. So with a block cipher, it is a ciphering process or a cipher that encrypts, so it decrypts in blocks, also referred to as rounds of bits. So instead of encrypting like characters like most encryption processes will do, a block cipher will encrypt in blocks or rounds of bits. So a block cipher could encrypt these 4 bits and then these 4 bits. So instead of encrypting like the number 28, for example, it would encrypt this and then encrypt this. Now we're going to get into this further in the course, and it might become a little bit more clear, but just try to follow along as much as you can. All right. Now we're going to talk about encoding, which is the last thing, and it's just a ciphering process that doesn't use a key. All right. So remember this vocab, I guess, is going to be pretty important as we dive into it. This module is probably the most important module, because if you don't understand these concepts, then you may not be ready to take the course. But if you really want to take this course, just study up, learn this vocab, and review this kind of concept of binary bits and bytes, and you'll be fine. All right. So now, one other thing I need to talk to you guys about is some cryptologic resources, right? So I'm gonna zoom in right here. So if you guys need any resources throughout this course, it's in the course overview. It's in the description. If you guys are taking this course on the website, it's on the bottom left button on the page, all right? It's called course overview. You click it, it takes you to the course overview. You click whatever module you're on, and it'll give you all the information you need, all right? This link takes you to the course home for this course, all right? Where you can, take it on the website. So you see, the website, you can take each module by yourself. You can just click on this one and you'll be watching the video right here. You'll have access to all this other stuff. Plus, if you enroll for $15, you can get a certificate once you finish this course. It's actually kind of cool. All right. Now the course overview, which is this page you're on right now, or this page right here, this is just another link for it. If you need third-party resources, I have the Wikipedia link for cryptography. It may not be the best resource, but it could help you understand a little bit more. Now, if you have any questions for me, if you want to get in contact with me, because I'm not always checking comments on YouTube and everything like that, you can join the Discord, which is linked right here, and ask me there, or ask anybody with the white hat label. You can also ask me on my website on the contact and information page, where you can just leave information here, ask your question, submit it, and I will get back to you as soon as I can. All right. So the last thing is homework. Now there's only like 2 or 3 homework assignments in this entire course, and they're super easy. I didn't want like annoying homework because it's supposed to be a fun course. So this homework assignment is you're literally reading an article. It's a 3-minute, 4-minute read. It's from my website actually, and it's about cryptography and the problems about repeated passwords. Again, yeah, see, 4-minute read. Just read it. It's super easy. That's it. Look how short that is. It's super short. I made sure that all the homework in this course was very easy and not like annoying or anything. So check out the article, read it, because it's going to be very important to understand for the next module. All right. So that's going to be it for this video. This is, module 1, and we're going to dive into module 2 in the next video. And module 2 is password hashing. Now, this is going to be a cool one because we're going to be talking about passwords, and this is why the Rocky article is very important to read. So read that article. Link is in the course overview, which is again linked in the description. If you guys are on the website, then you can click that little button on the bottom left. If you guys are also on the website and you want to quiz yourself, take the quiz on the bottom right button and make sure to mark this module as completed once you're done, so you can move on to the next one. All right. Anyways, make sure to leave a like on this video, subscribe to the whole YouTube algorithm thing, and I will see you guys in the next one. So stay happy, stay positive, and as always, happy hacking.